Here's a couple problems from your 8.1 to 8.3 that you've either left blank or I can tell you just guessed on these. And maybe it's some other terminology. It says determine the points of discontinuity. That means is where does this graph have a break? And breaks come from the denominator. Now if you have a graphing calculator, I would put it in there and that could help. If you have a graphing calculator, I would say x plus 6 in parentheses divided by x squared plus 9x plus 18. Then you can go to your table of values. So you'd press second graph. And there you would see the numbers. It would give you an x number and your y would say error. Everywhere it says error, those are your solutions. To do it algebraically, we're going to go ahead and factor this. Multiples of 18 that add to give you 9. Well, multiples of 18 are 1 and 18. 2 goes into it 9 times. 3 goes into it 6 times. 4 doesn't go into it. 5 doesn't go into it. And we're back to 6. So which add to give you 9? Those add to give you 9. So if I factor that bottom, I get x plus 3 and x plus 6. These two things are the same. They're factors of each other. Well, to figure out where they disconnect, I set each factor equal to 0 and solve. When I subtract 3 to the other side, I get x equals negative 3. There's one solution. When I subtract 6 to the other side, x equals negative 6. There's the second solution. Those two answers that are circled right here and right here in pink are your two solutions. The next problem says find the horizontal asymptotes. And the easiest way I can tell you to do this is to compare the numerator and denominator when they're the same exact degree. So right now, this is a 1 on the top and a 2 on the bottom. They're not the same degree. So if I add 0x squared, when I add 0 of anything, it doesn't really exist. But at least now I can state that they are the same degree. So what I'm going to do now is say y equals the coefficients of the ones that are the same degree. 0 over 6. Well, 0 over 6 simplifies to y equals 0. Therefore, that is my horizontal asymptote.